Alhamdulillah, summa salatu wa salam ala Rasulullah, Muhammad bin Abdullah, wa ala alihi wa sahabihi wa mawala wa ba'd. Evening, my listeners, my viewers, and my subscribers. I still remain my humble self, Akorede Oluwayinka Hassan at Swab's Academic Online Class. Today, inshallah, we are going to be seeing something on what? Types of mapping and function. Types of what? Mapping or what? Function. Are we together? Both goes along with one another. Am I communicating? Now, before we drill into this particular question being asked, as far as type of mapping is concerned, or function is concerned, let's quickly see what is even mapping and what is even function. Note that these two words came from what? A topic known as relation or relation. Anyhow you pronounce that. Relation or what? Relation. What do we mean by a relation or relation? What do we mean by that? As far as further math is concerned, a relation means a pair is a pair of order what? Ordered sets. A pair of what? Order sets. Then what do we mean by this pair of order sets? Are we together? Let's bring it down to when we have twin. We have the first one in our own dialect language. We have it to be taye. So when we have taye, surely we must have what? Kehinde. That is what we call pair of order sets. Are we together? Now let me relate it in terms of food. The food that we consume at home. We have rice. What goes with rice? What's suitable with rice? Beans. Beans with rice or rice with beans. We call that, as far as it is concerned, we call it relation. The rice and beans relating to one another, we call it what? Pair of what? Order set. Am I communicating? The same thing, husband and wife. Wife and the what? The husband. That is also pair of order set. Hope you've gotten that. Now, let's bring it back to the class here. Now, when we say pair of order set, what is it pairing? What and what are they pairing with one another? Are we together? Note that this relation gives birth to two offspring, which is mapping, which is what? Mapping, and what? Function. It gives birth to what? Mapping and what? Function. Are we together? And what is even mapping and what is even function? Know that mapping, are we together? As far as mapping is concerned, it has no rule. It can map, it can match or pair with anything. Are we together? As far as this topic is concerned. But note, be mindful of what is function. Function, it has rule. It has a specific rule. It has who to pair with. It doesn't pair anyhow. But as far as mapping is concerned, it pair with what? It pair with anything pairable. Are we together? So let's take note of that. Now, let me explain this using diagrammatic illustration. But as far as this question is concerned, we are not asked to use diagram to solve this. Are we together? This is an algebraic expression. As far as what? Types of what? Mapping is what? Is concerned. Hope I'm communicating. But let me quickly explain what do we mean by mapping and function in terms of using diagram. Now, when I have this is A, and this is B, and this is C, and I have this is 1, 2, and 3. This now, before relation can exist between this one and this one, are we together? We must what? We must match this with this one. But this first one, we call it domain. What do we call it? We call it domain. Or you call it what? Y, or you call it X input. Or X value. Why we call this one? We call it what? Codomain. And we also call it what? Y output. Are we together? That is what we call it. Now, the relationship that exists between them, between domain and codomain, is what we call relation. Are we together? So how do I relate this together? This we have, as far as this as you are seeing it like this, we haven't seen mapping there, rather we haven't seen function. We are going to match them together for we to see is it mapping or function. Now, so let's relate this with this: A to 1, B to what? 2, and C to what? 3. Now, relation have occurred, then mapping has also occurred, function has also occurred. But what type of, now how do we identify? This is a diagram. What? We are matching domain with what? Codomain. This is one element. This is another element. This is another element. This is element for the codomain. Element for the domain. Are we together? Now, A is relating to what? 1. The element of A is 1 in the codomain. The element of B is 2 in the codomain. The element of C is 3 in the what? Codomain. That relation has occurred. But if they ask you, is this particular diagram, is it mapping or function? Are we together? Firstly, note that not every mapping is function. Not every mapping can be called what? Function. But every function can be called what? Mapping. Let's take note of that. How do we identify if a what? This diagram like this, if it is what? If it is mapping or function. Are we together? The first thing you need to do is that note each element in the domain must not be pairing to 2 or 3. It must pair with only what? A single element in the codomain. When element inside domain is pairing to just a single element, each of them is pairing to only a single element in the codomain. We call it, what type of mapping system is that? We call it function. So this particular one, you can see A only match with what? What element in the codomain? 1. B only match with what element in the codomain? 2. C only match with what element in the codomain? 3. So when every element here, when they are matching with only specific element in the codomain, we call this type of mapping. When they ask you to identify, is it mapping or function? This one becomes what now? Function, not mapping. Because I told you earlier that it has to, X input must not be what? Pairing to more than 1. It must be specific. It must pair only with what? A single element. When we have A pairing more than 1 here, are we together? It becomes what? Mapping, not function. What do I mean by that? This is what I mean. When I have this like this is A, B, and C. We have this. We have 1, 2, 3, and we have A pairing to this, and A also pairing to this. Are we together? So we have maybe B pairing like this, C also pairing to this. Are we together? We don't call this one. We don't call it what? We don't call it function. What do we call this one? We call it mapping. Because I told you earlier that as far as domain is concerned, all the elements or each element in the what domain must not pair more than 1. They must pair only 1. They must not be pairing. A now is having element of A is 1, as an element of A is also what? 2. This is mapping. If you are asked to identify this diagram, we call this diagram now, is it mapping or function? This is what now? Mapping. But look at this one. This is now function. That is why I said this is mapping. Because I told you earlier, every function is what? Mapping. But not every, this is mapping now. But not every mapping is function. Hope that is noted. Well noted. So this is mapping now. If you are asked to identify this one, it's mapping. No, that is not what we are asked to do. But I quickly explain what do we mean by relation. I hope you've gotten the definition of that. And what are the offspring? As far as relation, and I've explained what is mapping now. We've discussed what is function. I've brought out a diagram illustrating identifying function, and I've what? Specified a diagram illustrating mapping alone. Are we together? Now let's go to the main work. What is the main work? Types of mapping or function. We have different type of mapping or function. Are we? We have number one. Let me clean this up. Are we together? We have number one. That is the main thing. And this question, as far as this question is concerned, we are not asked to use diagram to solve this question. We are asked to solve this question using algebraic what? Now the question being given is in algebraic form. We are asked to solve it algebraically. Are we together? How do we solve that? Since we've understood what we know as relation and what is mapping, and how do we identify function. Now let's go to the main work. Type of mapping on function. We have different type of mapping on function, but due to the what? Due to the time constraint, let's quickly look into three. We have number one. Let me start with what the question asks us to do. Well, let's see. If function of what? Of codomain and redomain is this capital R, it represents real. That means the codomain is real, and the what? The domain is also what? Real. That means the what? The output what? Output what? Output y output. Sorry, y output is real, and the what? X input is also what? Real. That is what they mean by this and this. So when they use capital R, that is what they mean. It's given that function of x is 1 over 3x is f of x. This is the main point, main bone of contention. Is f of x. That means function of x, is it injective or what? Is it injective and also what? Surjective. How do we know? As far as this question is concerned, this is function of x. This is 1 over 3. Is 1 over 3, is it injective? And if it is injective, is it also surjective? How do we know that? It has condition. But before we dwell into that, let's quickly see. We have type of mapping and function. Number one, we have injective. What do I call it? Injective. And another name we call injective. We call it one-to-one mapping. What do I call it? Another name in some text, we call it what? One to what? To one mapping. Mapping. Are we together? Then the second one, we have what? Surjective. Surjective. What do we call that? We call it another name. We call it onto mapping. What do I call it? Onto mapping. That is another name. Is it that you call it? So that means they can reverse this question by saying, is f of s, is it what? Is it one-to-one or what? Or onto mapping? It's still the same thing as injective and what? Surjective. Are we together? Let's take note of that. Number three, we have what we know that bijective mapping. Are we together? We still have four. We have constant mapping. Are we together? And so on. Identity mapping. But because of the time frame, let me just limit myself to this just three. Are we together? So firstly, let's understand what we know as injective. Injective means, let me use this diagram to explain injective. Injective means every element in the what? In the domain, that is in the x input, x value must has a specific what? A specific what? Element or image in the codomain. Are we together? So meaning A must only pair with only single what? Element in the codomain. As you can see, A to 1, B to 2, C to 3. This type of mapping, this type of function or mapping, we call it what? Injective. Hope I'm communicating. We call it injective mapping. Are we together? That means what is injective now? Injective is what? When we have every element of the domain or S input must pair to only a distinct or a specific image or element in the codomain. That is injective. Now let's see. Are we together? So I've used diagram to what? To explain that. Are we? But we are not asked to use diagram. We are not given any diagram to what? To explain injective and surjective. But once you get this, you can. Now let me bring one. What of if I'm having it like this? Maybe I have D here. Are we together? And I have maybe I have D here. Are we together? And there's nothing here. Are we together? Now, can we call this injective? No. Because we say every one of them, A, B, C, D, they must be what? They must be pairing with a specific what? Specific image or element in the codomain. This D now, is it pairing to anything? So we don't call it injective. Are we together? That is how you know. Diagrammatically, if they bring diagram under mapping system, if you want to identify if it is injective, every element here, A, you can see is pairing to. This one is not pairing, you don't call it injective. And they must not be overlapping. That is another one. They must not be what? They must not be what? Overlapping. A, B, C. And we have maybe 1, 2, 3. Maybe B2 like this, and we have A like this. You don't call it this one. You don't call it what? Injective. They must not be overlapping like this. That is what I mean. And what again? Like, they must not be overlapping. In what sense? They must not be like this. Maybe like this. They must not. That is what I mean by that. Now let's quickly go to, that is all about injective. That is the definition of injective. What about surjective? Surjective is the what? Opposite form of injective. That means every element in the what? In the codomain must have a what? Must have at least one element in the what? In the domain. Are we together? Reverse is the case. Are we together? Like I'm having, then they can overlap. So maybe I have A here, I have B here, I have C here. Are we? I have 1, 2, 3. Are we together? Now, this is codomain. This is domain. That means every element here must partake in the relation. Meaning this can pair with this one. Are we together? Sorry. This can pair like this. They can pair like this. They can pair like this. We can also call, you can see every one of them, they are what? They are relating with at least a specific. This, for surjective, it can be pairing. Every element in the codomain here can pair at more than 2. But you know, for injective, at least 1. But for surjective, codomain can pair, one can be pairing with A. This one can also be pairing with B. Are we together? Or like this. At least this is a surjective. You know, this is a injective and as well surjective. Are we together? Or you can have it like this. Domain A, B, C, 1, 2, 3. C can be pairing like this. Or it can pair like this. C can pair to 2 and can pair to this. And A can pair like this. This kind of, this is domain, this is codomain. You can see every one of them, they are pairing with something. They are what? They are pairing with, we call this type of mapping system, we call it what? Surjective. Every one of the codomain must be pairing with at least a single. They can pair more. You can see C is pairing to 2. Codomain that is here, 2, 3 is pairing to C. Are we together? That is that. Now that is not what we are doing. What we are asked to do. I just explained that. Are we together? Now what we are asked to do practically is that, let's look. What I explained earlier now is in terms of diagrammatic what? Explanation. What we are asked to do is that we should solve this algebraically to know is it injective or surjective. Now I've explained what is injective. I've explained surjective. Every element in the codomain must be relating with at least 1 or 2 elements. With at least 1, or it can relate to more than 2 in the domain. Every element in the domain must be what? Picking a distinct element in the codomain. That is injective. Now, as far as this is concerned, we are not asked to solve this like that. Note that for the injective, let me make it like this. For this question, let's go to this question now. For this question, like we are seeing on the board like this, we are asked to note, is it f of s for this, is it injective? It has conditions. It asks what? For a question to be, since we are not given diagram, for a question to be injective or surjective, the injective has its own condition, surjective has its own condition, as far as we are not given diagram. What I explained earlier is when we are given diagram. If you ask to identify if a question is surjective or injective. But here we are not given diagram. All we need to know, Please note the condition for a question like this to be injective. What are the conditions? Condition 1 for a question to be injective. You must be given f of x. That is 1. Condition 2, are we together? You must change, you must determine, let me make it like you must determine your f of y. That is condition 2. Condition 3, you must equate f of s and f of y. I will explain that. Then condition 4, for a question like this to be injective, you must what? You must, if x equals y, then it is what? It is injective. You can say all these things. Yeah, how is it related to this? You like be wondering how will I relate all these things with this? It is very easy and simple. Now, these are the 4 conditions you need to know as far as you are not the given diagram. Your f of s must be known. You must determine your f of y. You must equate f of s and f of y, and you must solve it getting x and y. If x is equals to y or y is equals to x, then that question is what? Injective. Are we together? Now let's try and solve that first. Are we given? Let's go to condition 1. What is the question? Let me write it. F of s is equals to what? 1 over 3x. Now for the first condition, are we given f of s? Now what is f of s? 1 over 3s. That is condition 1. Let's go to, we want to know if this question, if f of s is it injective. Now let's go to second one. Determine f of y. How do we determine f of y? It's very simple and straightforward. Wherever you are seeing x here, you will change it to what? Y. What would that be? F, we are under condition 2 now. F in a bracket. What do we change s to? Y. Then what follow? 1 over 3. What do we change this s to? Y. This is how you determine your, we've determined our what? F of y. This is f of y. Wherever I'm seeing x, I will change it to what? Y. We have, this is condition 1. We've gotten to condition 2. What is the next one? Equate what? F of s and what? F of y. What do they mean by? That means you need to write your f of, this is condition 3. You need to write your, this is f of s, this is f of s. What is f of s? 1 over 3s. What is f of y? 1 over 3y. Then you equate them, meaning you let them equals to one another. What is our f of s? What do we have? 1 over 3s equals to, what is our f of y? 1 over what? 1 over 3y. Are we together? Hope everything we've got into this is very easy. Now, what do we do in order to go to this condition? What do we do? Let's cross multiply. 3y times 1, what would that be? 3s times 1, we are cross multiplying here to determine the what? The last condition for we to know is it injective. If we solve this, if we simplify this and it's not giving us only s and s equals y or y equals x, that means the question is not what? Injective. But when I solve all this one and is at the end of the day is bringing s and y, s equals y, that means the question is what? Injective. Now let's see, 3s times 1, we are cross multiplying 3s. Sorry. 3s equals to what? 1 times 3y, what would that be? 3y. Then what is the next thing I will do? We are seeing 3 here, we are seeing what here? 3 here. You equate them. What are we left with? We are left with x equals to, this is equals to, s equals to what? Y. Now s equals to y, is it? And we said for the last condition, when you solve everything and you later arrive at s equals to y, that question is what? Injective. This question is now what? Injective. Let's quickly go to surjective. Are we together? Hope that is noted. That is how you solve. It's very easy. Should I clear this one now? Now let's see if it is surjective. Now for surjective, let me clean this. For surjective, so you can see I solve all this without using diagram. That is how. It's very easy. For surjective, it also has its own conditions. Its own condition is different from this one. Condition for what? Let me make it like this. For what? Surjective. That is onto what? Another name. Onto what? Onto mapping. Another name we call surjective. Now, you must, for the condition 1 for surjective, you must also be given f of s. Are we? For condition 2, for what? For surjective, hope you are with me. You must change your f of s. F of s, its own condition, it is different from that of the injective. F of s, you must change it to what? Y. Wherever I see f of s, I'll be changing it to what? Y. Then condition 3, are we together? You must make s the what? The subject of the what? Of the formula. After changing your your what? Your f of s to be y. Are we? Then condition what? Condition 4, insert. You then insert. Are we together? You insert the value of your what? You insert the value of your what? Your x into f of x. Are we together? Then the last one, if f of x equals y, that means when we solve everything and our f of s later equals y, that question is what? Surjective. Now let's apply all these things. You don't need to cram, just apply this. Determine, you must be given your f of s, then determine, change your f of s to y, make s the subject of the what? Of the formula. After you have changing it to what? F of s to y, then insert your x into the what? That means you insert your x value into the what? F of s, and when you simplify that, you must arrive to this. Are we together? Now let's apply all these conditions. When we want to see if the same question, we've seen that it is injective. Is it also surjective? Now let's go to the first condition. Are we given f of s? None. What is our f of s? Solution. F of s, solution. What is our f of s? Our f of s is what? 1 over what? 3x. Are we together? What is the next thing? Determine, change your what? Don't let me. Change your f of s to be y. Or let your f of s to be what? Let f of s to be what? Y. Now, wherever I'm seeing f of s, what will I be putting? Y. It will now be y equals to 1 over what? 3s. This is condition 1. This is condition 2. Let's move to the what? Third condition. Make s the subject of the formula. After changing your what? Or f of s to be y. Here, you make s the subject of the formula. Is that noted? Now let's make s the subject of the formula. How do we? Let's cross multiply. Y times this one. In order to make s the subject of the formula, you cross multiply. Put 1 here. 3s times y. What would that be? 3s times y equals to 1 times 1. What would that be? 1. Am I communicating? Now what is blocking s? What is blocking s? 3. And what is blocking it? Y. Now let's divide through by 3 and what? And y. Divide this by 3 and y. This settles this. Y settles this. We are left with what? X. X now will now be 1 over what? 3y. We've make our what? We've satisfied the condition 3. Make s the subject of the formula. Then insert x into fs. Where is our fs? Go back to this. This, what do we get for the value of x? 1 over 3y. Then whenever I'm seeing s, we are seeing s here. I'll slot in what there? 1 over what? 3y. Are we together? Now, the next thing I'll do, we are under condition 4. This is condition what now? Condition 3. Condition 4. Let's go to f of s. What is f of s? F of s equals to what? 1 over 3x. Are we together? Now, the next thing I'll do, we want to know, is it also surjective or onto what? Onto mapping. Are we together? Now, what do we have? Wherever I'm seeing x, the meaning is wherever I'm seeing x, what will I be putting? 1 over 3y. What would that be? it will now be f of x equals to 1 over 3 and x. What is the sign that is joining them? Times, right? It will now be 3, open a bracket. What is our what? What is our x? Our x, what is the value? 1 over 3 what? 3y. So this is 3x. I'm seeing x here. So I will change x to 1 over what? 3y. What would that be? 1 over 3y. Then what is the next thing I'll do? 3 can settle 3 here. What are we left with? F of x equals to what? 1 over 1. There's 1 here. The one, initial one that is here. There's 1 here. Over what? Over what? We are left with what here? Y. Are we together? Now the next thing, let's go to this last condition. If f of s, this is f of s. F of s is now 1 over y. If you can simplify it to the extent that f of s we will later get it to be what? Y. That means it is what? Surjective. Then let's try and simplify this. For we to know, is it going to give what? F of s will it equals to y? Now in order to, let's see, f of s equals to, now in order to break this, what is our, where is our big divide between this and this? Where is the up one? It will now be 1. This is the big divide by, what are we having? This 1 over y. Then try and change this one to times. This one will go up, this one will come down. What would that be? F of x will be 1 times y over 1. F of x will now be 1 times y. Y. Where there is invisible what? 1 there. 1 times 1. 1. Right? It will now be f of x will now be y divided by 1. Y. So now f of x is giving us what? Y. Now that means the question is also what? The same question is also what? Surjective. Are we together? We've answered what we have to. So note, the only thing you need to know here, understand the two conditions for injective and what? Surjective. And this is how you solve that. So now you can arrive to the answer that what? Both this question is injective and what? Surjective. Now the third one, we mentioned that this is one type of mapping. This is another type of mapping. I mentioned earlier bijective. When you see a question, when you solve a question, that question is injective. And at the same time, when you solve that the same question, and it's also surjective, we call it bijective. Bijective means when a question is injective, and when you also solve it, the same that question is also what? Surjective. So we call it what? Bijective. So that is that on that. So in this video now, we've explained what is relation. We've explained types of relation, which is mapping and function. We've explained how to identify mapping and function. We've explained diagrammatic illustration of mapping. And we've explained condition to know if a question is what? Injective. And condition to know if a question is what? Surjective. And we've explained what is even injective and what is what? Surjective. And we've explained bijective. When you solve a question and you are getting the same thing, we use different conditions. When we get the same question, we get it to be injective, and we also the same question, you get it to be surjective. We call that type of question. In case you are asked to, we can call this type of question. We can also call it what? That the f of s is also what? Bijective. Apart from surjective, we can also call f of s here bijective. It satisfies three types of what? Mapping system. Now my assignment for you, as you are watching me, my assignment for you now, please don't forget to like, share, and also what? Subscribe. My assignment for you now is that let's try and change these parameters, and you apply that, use it to solve what? Is f of s, is it surjective? Let me just change this to 3s plus 1 over 3s minus 1. Now, if f of codomain is real and what? The domain is also real, it's given that f of s is 3s plus 1 over 3s minus 1. Is f of s, is it injective or surjective? And if it is injective, when you solve this, based on the two conditions that I gave you earlier, when you solve this, is it also bijective? So if after you solve this, and it is injective, you solve it also, it is subjective, then that means you concluded that it's also what? Bijective. I still remain my humble self, Akorede Oluwayinke Hassan, a Source Academic online class. Do not forget to like, share, and also what? Comment. And like our video, and also share to the needies. Barakallahu feekum as you are watching.